with standard synchronous code, it kind of makes sense that you can easily store data because one thing loads after another. The final thing might be actually storing the data. With asynchronous code, it might not work out that way, and it can cause a lot of frustration and unneeded complexity. So what I want to do is actually separate the two, get the scraping portion done first, get all the data I want from that scraping event, and then store it. And it's really subtle of a difference, but we actually already are mostly set up for this. So if we actually scroll up a little bit, the print statement that I get from the run is actually a list of things I want to store. So no matter how many things I'm running here, so no matter how big this ends up being, as long as my computer has enough memory to hold it, which it definitely will, because this is not big content here. I'm going to go ahead and actually store this directly into Pandas itself. So this async function of store links as a data frame pickle, we can still keep it as an asynchronous function. That's okay. The thing that I want to change, especially because I'm going to have a lot of URLs soon, is how it's actually called. It's really simple. So we cut this out here from our run function and we paste it here, right? So we want those results there. We put the results here, and now I can actually put df.head and we'll run that one now. And we'll just see what happens with this. So Python, run that. And of course I get this await can't be outside a function. Well, that's because I'm outside of that loop, right? So let's go ahead and get rid of await. And naturally this is a coroutine now, and it's not actually gonna give me that data frame, right? So what we can do is, well, let's go ahead and try asyncio.run. And what do you know? It actually gives us that data. But the thing is, we're actually not getting a lot of benefit from it being asynchronous right now. So let's just get rid of that. And so now we'll leave it in as just store links as data frame. We don't need to run asyncio on it. And now it's actually going to store that data frame as we want. But I also want to actually set up the name for this. So we'll go ahead and say name equals to links.pickle. And I'll go ahead and pass the name in here as well. That way our storing link as pickle does work, right? The other part of this is, well, what if there's not already a file called links.pickle? Or what if there is already a file? Well, how it's set up right now is it's actually not combining the pre-existing data with the new data. So I actually want to combine the pre-existing data with the new data. So this is going to say this is a new data frame, and then our old data frame is equal to pd.readPickle, and then our name. And of course, if you were using CSV, you would just do read CSV, okay? And then you would set the index most likely. But here we've got two data frames here. And so now I can just say df equals to pd.concat. And what that will do is concatenate a list of data frames in the order you put it. So ogdf and new df. All this is doing is appending from my original data frame to my new data frame. And that actually looks pretty good, except one problem. If the one I'm trying to load doesn't already exist, well, what happens then? Well, we can just make a simple command for this. So we'll go ahead and say ogdf equals to, well, pd.dataFrame, and we'll pass in a list of items here. Really simple. I'm just going to have literally one item in here. And I want it to be ID because we're going to be setting this index of ID. Now what I'll do is say if pathlib.path of this name, or whatever that path would end up being, .exists, then we'll go ahead and read that one in, changing what that is right there. Okay, so I'm going to go ahead and run this with a different title. Maybe just call it link this time. And we'll go ahead and run this. And so hopefully what happens is it actually stores only the new data frame, right? And looks like it has. Let's go ahead and go into our home page here. and I've got link.pickle that's working. And so let's go ahead and load that one in, and we'll go pd.read pickle and call that data frame, and then df.head, and hopefully we see this exact same data. Looks like we do. Okay, so notice this first row is non, as in NaN, not a number. So that's actually not a valid row, but it did show me that my creation of a data frame actually ended up working. Now, the reason I do it this way is just to initialize a blank data frame if my other one does not exist. Because now, going forward, it's no longer going to need that one, right? So what I want to do then is after this set index, literally after, it's got to be after, we're going to go ahead and do df.drop NA, and we'll do in place equals to true. And then that way, that first row, this row we don't actually need, ends up going away, okay? So there is one more aspect of that we want to change, and that is getting rid of duplicate IDs. That's going to happen all the time, right? Yet another reason to have it as its own synchronous blocking function, that we're getting rid of all of this stuff. We're doing a lot of processing on the data frame right here. And so I'll go ahead and say df equals to df.loc. And what we're doing here is we're going to look for the df.index. Now, the reason I'm using index is because we set the index to that ID. If I wasn't setting the index to that ID, I would just grab the ID column, and we'll say duplicated and keep equals to first. All right? So all this is doing is taking a slice of the data frame as long as these items aren't duplicated. So in a way, it's actually dropping the duplicates. There are other ways to do this, but this allows me to actually have the first one that shows up, which is actually going to be coming from my original data frame. This, of course, is so my actual final data frame doesn't get concatenated over and over and over again and just become a giant data frame of repeating data. So actually, if I leave this out, I'm going to go ahead and leave it out for just a moment, and we will print out just df.shape here. We've got 85 rows, okay? So if I do that same scraping, I should actually double that number. I mean, I might actually lose, maybe it'll be 84 rows and then double that number. But let's go ahead and try this out. It actually did about double, right? So 85 times 2 is roughly this, but one of the rows is missing, and that's ID. Okay, so it actually did work as far as the scraping is concerned, but now we just want to get rid of all those duplicates. So I'll save that, run it again. All right, so we get this silly syntax error here. It shouldn't have been an exclamation mark. It should have been a tilde. But what actually happens now is I actually see some challenges with this. So I set this index and then I drop the previous one, which means I might actually accidentally delete the IDs, which is certainly not something I want to do. So instead of setting the index there, what I'm going to go ahead and do is say df.reset index, and we'll go ahead and do in place equals to true, and then drop is definitely going to be false. That's the default anyway. So that's going to reset the index and add a whole new column for us. So what that also means is down here, I actually want to change this from being index to then being back to ID. So we absolutely only want one of those IDs. It could be first or last. It doesn't actually matter. Last would be the most recent one. So that now gives me a new data frame. So in that data frame, I could go ahead and drop any unknown values here. What I also want to do is declare inside of that data frame the columns that I want. So the columns that I want are ID, slug, path, and scraped, right? So ID, slug, path, and scraped. So this right here is going to offset any additional indices that are created, right? Because I'm not actually dropping any of them, so that means that I might actually accidentally add some of them. So this takes care of that. And from that, we could actually remove, or actually move these here, just to make it a little bit better all around, right? So we concat, reset the index, and then we only get the columns that we want. Then we duplicate it. And again, we could set the index for that ID value here, or we could just leave it as is. I actually do want to set the index back into being that ID. So df.set index being to ID, and in place equals to true, and drop equals to true as well. So the reason I can drop it, or I know with confidence that I can drop it, is because I reset it first, and then I can drop it second. All right, so let's go ahead and run that again. So we should get the exact same shape. Like it's not necessarily going to override things. In this case, it looks like I might have not scraped anything, or I'm making a brand new link.py, or pickle rather. Okay, so there it is. So if I run this again, it should append if there's anything to append to, or it should give me roughly the exact same thing back, or maybe a few additional ones in there. All right, so I run that again, and there it is. So see how I'm getting this challenge here. So this one right here is giving me not a number for my ID. So that is the exact reason why I'm actually going to not set that as an index, because there's that really high probability that perhaps I'm losing that value. And that's something I do not want to do. And since I'm dropping the index, resetting the index, I'm doing a number of those things, I don't want to accidentally remove a row that actually has an ID for this content, right? It's not true for every content or every piece, which is another reason why to even consider further, just scrape all that data, get this big old, list of data set, and then clean it up later, right? So I'm actually trying to clean it now, probably a little prematurely, but these links are ones that I still want to scrape. So that's the other part of this, is like we actually want a fairly clean idea of all of these links in here, so then I eventually do actually scrape them out. Okay, so now with that, I removed that index, and if I have to reset it, that would be fine. Like if I reset it again, no worries there, because I'm actually getting it here. But let's go ahead and run this now. And I'll also do df.head, and we'll say n equals to 100. And so what I'm not seeing so far is IDs being null. The index, or the NSE value itself, is not necessarily correct. So the top 10 is giving me starting at 85. It's not starting at 0. So perhaps we'd want to change that as well. But for now, this is fine. This is actually good enough. The NX value doesn't matter to us. It's these four that do. And so now what we need to do is actually be able to scrape each one of these things and then update whatever the name of this is. But before I do that, I absolutely need to change some stuff related to this on how we pass the various items in here too. So let's keep going.